Hi everyone. Today we're going to study magnitude of cross product as area of parallelogram. So we use the symbol here, the magnitude of vector A times vector B as area of parallelogram. Given a parallelogram, we assign some values. So the base is the vector A, the side here is the vector B. And we assign this angle here to be angle theta. Now let us assign the height h. From the right triangle form, we can say that sine theta equals h, or the height, all over the magnitude of vector b. Manipulating this, we will get the value of h equals the length of vector b times sine theta. Now for the area of parallelogram, that is equal to base times height. Looking at our figure, the base here is the vector A, and the height h, that the value is in here. Let us substitute the corresponding values. So we have here the length of vector A times the length of vector B times the length of sine theta. So by definition of cross product, we can simplify this expression into the magnitude or length of vector A times vector B. This is now our working formula. Example, find the area of a parallelogram with adjacent sides. Vector A equals I plus 2j plus k, and vector B equals negative I plus j minus k. Let us write our formula for the area of parallelogram, and it's here now. So for step 1, let us first evaluate vector A times vector B. We write our 3 by 3 matrix respectively. So we have I, j, k for the first row. Second row is the 1, 2, 1. These are the coefficients of the components of vector A. The last row, negative 1, 1, negative 1. The coefficients of components of vector B. By the definition of determinants, we'll have component I times the square matrix 2, 1, 1, negative 1, minus component J times the square matrix 1, 1, negative 1, negative 1, plus component K times the square matrix 1, 2, negative 1, 1. Evaluating the determinants, we have now component I times the quantity 2 times negative 1 is negative 2, minus 1 times 1 is 1. Then minus component J times the quantity 1 times negative 1 is negative 1, minus negative 1 times 1 is negative 1, plus component K times the quantity 1 times 1 is 1, minus negative 1 times 2 is negative 2. Simplifying further, negative 2 minus 1 will be negative 3 times I. So we have 3I. Minus component J times negative 1 minus negative 1. So we can cancel this because this becomes negative 1 plus 1. Component J is deleted. Plus component K times 1 minus negative 2. So it becomes 3K, and we copy it here. This is now the cross product vector A times vector B. Now for step 2, let us evaluate the length of vector A times vector B. Our formula is this big square root x squared plus y squared plus z squared. The values x, y, z are coefficients of the components I, j, k respectively. Evaluating the corresponding values, we have now the big square root of coefficient of I, that is negative 3, and we put the square, plus, there is no j here. It means coefficient is 0. Then we put the square, plus coefficient of k, which is 3. We write here 3 square. Simplifying further, we have now the big square root of 9 plus 9. We can simplify this further into 3 square root of 2. And since this is an area, we write square units. This is now the final answer. I hope you learned something from this video. See you again next time.